Hello world, my name is Mohammed Responding, and in this video what we're going to do is I'm going to show you how we can apply brightness and contrast to an image. So we still have our Eiffel Tower image and we have our gray Eiffel Tower and our grayscale version. So I'm just going to create another file, call it something like that. And obviously we need to import CV2. We also need to import NumPy as NP. And by default you should already have NumPy installed, so this shouldn't be an issue. But in the event it is, what you can do, I'll show you how you can install it. You can run sudo apt-get install python numpy. Ask you for your password. I already have the newest version, but that should be the command. You want to install sudo apt-get install python-numpy. And that should install NumPy. And the reason we're going to need this is because we have to configure the dimensions of source 2 so that it's the same as source 1, even though we're not actually going to be using it, so we just fill it with zeros. There still has to be a valid matrix there, it just doesn't have to mean anything. So first thing we're going to do is we are going to load the image. So if you remember from the last time we did Python, it should be cv2.imread Eiffel Tower dot, and we're just going to use the original one. And we're not going to convert to grayscale, so just so that we can see the brightness and contrast more clearly in the in the original RGB image instead of the grayscale image. So I'll create a new. Well, first of all, I should just solidify the constants. So I'm just going to multiply everything by 2, and I'm going to set my beta to 50. So the contrast, I'm going to multiply by 2, and for the brightness, we'll just say add something like 50. So let's get a result. So cv2.add weighted, pass in the original image, pass in alpha, and then for source 2, we're just going to use some zeros. And they're going to be the same shape as, and the type, data type, that's what dtype means. The same shape and data type as our original image, but they're just going to be zeros. Pass in 0 for the add weighted beta, but pass in beta for the gamma. It's kind of confusing with all the constants, but if you go back to the previous video when we talked about how you can convert the add weighted equation to the brightness contrast equation, you can see why. Now I want to save this image, so I can do cv2.imwrite. We'll call this Eiffel Tower BC for brightness and contrast. JPEG, and pass in the result. Okay, so I'm going to save this and I'm going to run this. It'll take a second, and let me open up the folder. You can see that here is our brightness and contrast, and here is our original. So yeah, you can see how the brightness and contrast really has an effect. All the values here, you can see, are much lighter, and that's what brightness does. It increases the pixel values. That's what it means to be bright, right? Because 0 is black, but 255 is like white. So if you add a constant, then you're increasing the brightness. And the contrast will do is, if the image is dark, it's not going to increase this as much because it's a multiplication. But now if the image is if the pixel value is like 2, it'll increase it to 4. But if the pixel value is 100, it'll increase it to 200. That's what contrast is, right? It's just the difference. It's just the difference between the dark and the light. In this case, it's a contrast of 2s, pretty big. You can see here. In fact, that these are actually just like pure white. So what we're going to do now is I just want to give you a quick little exercise before we move on to image blending. So let me turn the page here. So suppose I give you a really small image. So maybe this has something like 7, 15, 135, 0, 255, 80, 120, 110, 5. Suppose I give you like a very simple matrix like this, and what I want you guys to do is, given my alpha of 2 and my beta of 50, I want you to write down what you think the resulting image will be. So here's the equation. Plus beta. And I want you to draw out what you think the resulting image will be. And what you have to remember is you want to apply this function to each one of these values. It doesn't really matter how you start because they're not dependent on the order, but you just want to apply this to each one of these values. So we'll pause the video right now, and you come back when you think you have a solution, and I'll share with you my solution. Okay, so let's kind of work our way through this. So we'll start on the top left. So multiply by 2, which is 14, plus 50, which is 64. Here, 0 times 2 is 0, plus 50 is 50. For 120 times 2 is 240. 240 plus 50 is greater than 255. And remember that all these values have to be between 0 and 255. So if you reach something that's greater than 255, you just truncate it and leave it at 255. So it's going to be the case for this, and if you follow the same logic, it's also going to be the same case for this and for this as well, right? Because 135 times 2 is something like, somewhere roughly like 260, but if you add 50 already, it's already greater anyway. So we'll just leave this at like 255. 15 times 2 is 30, 30 plus 50 is 80. 110 times 2 is 220, plus 50 is going to be truncated. 5 times 2 is 10, 10 plus 50 is 60. 80 times 2 is 160, plus 50 is 210. So this should be the resulting image that you get after applying a brightness and contrast. And as you can see, you kind of get what we expect here, in the sense that 0 is black, and these are much higher values. So when you multiply by 2 and add 50, this becomes a little bit brighter, sure, but this is way brighter, right? In fact, it's pure white. Anyway, that is just sort of an example. Hopefully you got it. If you didn't, or if you have any questions on how this computation works, please leave something in the comments. But yeah, that is brightness and contrast. So in this video, I showed you how we can use brightness and contrast in the Python code, and we even did a little example. So in the next video, we're going to get into image blending. So I hope to see you all in the next video.